Okay, my attempt at trying to explain psychometrics. Firstly, I want to go over design conditions. Someone had asked about that, so I'll do it really quickly. I write this before I start any test. I think it's very important to have, even if you're good, it's just good. So supply air, many of you may know this already, return air to S saturated suction temperature to your suction line temperature. Then you have DA, discharge air, to outside ambient air to saturated condensing temperature to liquid line temp, TD, evaporator delta T, condenser delta T, superheat, subcool. I always start with the TDs. It is minus 40 under design conditions for your evaporator, and it is plus 30 for your condenser. Your delta T is half your TD, so it'll be plus 20 over here, and it'll be minus 15. Superheat under design conditions is plus 15, and subcool is minus 10. This helps me so much. If you don't know, now you do. Like, for an example, if you're given anything, you can figure it out. Saturated suction, let's say it's 65, right? And you need to get to your supply air. You just follow the process. So 65 plus 15, we're going to do minus because we're going left, so it's the opposite. So 65 minus 15 is 50. Then we're going to not minus 40, but add 40, which brings it to 90. And then we're going to subtract 20, not add it, which brings us to 70. Right? Pretty simple. That's under design conditions. Okay. Also, I'm doing this blind. I'm doing this assignment blind, so forgive me if this video takes forever. I'll probably point out some cues when I post it. Anyways, psychometrics. With psychometrics, you're always given your wet bulb, right? Your dry bulb. Your dry bulb, I believe, could just be the reading on your temperature, right? If it's 72, you're going to find 72 here and draw a line up. Your dry bulb is always a vertical line. And then you just need one more piece of information before you can graph. And that information could come from relative humidity. So, like, for example, let's say the relative humidity was 10. I don't know why my phone's so blurry. That's 10, right? You could just follow the relative humidity until it intersects with that dry bulb line, make a dot, and then you're going to follow the line. Obviously, you want to use a ruler. That'll give you your wet bulb, which your wet bulb is always diagonal. It'll give you your BTU in that moment. And from there, you can draw a straight line to get your grains, right? If, let's say, we're at 105 and we're given a wet bulb of 65, we're going to find that 65, and we're just going to follow that line all the way down. And it intersects right there, which will also do your horizontal line. From that point, will give you your grains, and what is that, 34, let's say, 34. Pretty simple, right? And also, with that diagonal, you're going to keep going, and that'll give you your BTU. Is that an hour or pound? BTU per pound? I'm unsure about that. Anyways, let's go through the first problem. So we got an air conditioning has a return air of 78 degrees dry bulb, 65 wet, supply air of 57, dry bulb and 54 wet bulb. If the system was moving 1,000 CFM, how many BTUs are being removed from the air every hour? So what formulas do we have? We have our sensible heat formula, but I believe we want to do our total heat formula. Yeah, let's try that. So total heat is 4.5 times CFM times delta H. Okay, so we need to figure out what delta H is. Delta H will be the difference in the BTU output in that moment. So we have a return air of 78, so dry bulb. So we're going to find 78, which, oh, I don't like this graph. Okay, let's just say it's right there. $78. Oh no. Where's my ruler? The fuck? Where's my ruler? Oh, there it is. So we find our 78. And you want to be parallel to the line. 78. I like to do my evaporators. I do it with a pencil, and then I come in with a blue highlighter. Blue for evaporator, low pressure. Right? So we got that. Our next piece of information is a wet bulb of 65, right? So we are going to find 65, and we're going to follow this line down until it intersects, like so. 65. And we're going to push it out past the BTUs because we get two birds stoned at once here. Okay. All right. So now we have that point. Now we can get all of our other informations. So we had the wet bulb. We pushed it out to get our BTU, which that would be 30, right on the money. So this is going to be 30 BTU. Hold on, it's bugging me that I don't know if it's pound or BTU. Sorry, just give me a second. What the fuck? Yeah, it's per pound. It's per pound. Per pound. Next, we're going to, from this point, we're going to draw a horizontal line to get our grains. And really, that's kind of all we need to do right there. Put a point, make it parallel with that line below, and just draw it straight across. I like to make, oh gosh, I like to make this line orange for some reason. All right. And then that gives us, not that we need it, but that gives us, that gives us what? 55, 56, 57, 58 grains. That's kind of irrelevant. We need to do the other plot. We need to find the differences between the BTU per pound for the in and the outlet, inlet and outlet. So we got supply air 57 and a wet bulb of 54. So 57 is going to be 55, 56, 57. We'll say right there. And this is still the evaporators. I use my pink highlighter for condenser. And then a wet bulb of 54. So 54 is right here. So we're going to draw that diagonal like so. This equals 21, 22, let's say 22.5. 22.5 BTU per pound. Right, so your delta H, which is what we need, right? We know that the CFM is 1,000, said that in the question. Our delta H is the difference between these two, which is 30 minus 22.5, which gives us 7.5. So 7.5. Right? 4.5. Now we'll do the math on that. So 4.5 times 1,000 times 7.5 equals 33,750. Now the answers are 33,300. So I'm just accounting for human error there. And that first answer is going to be 12 minutes. Holy shit. I am so sorry, but if you wanted help, I'm sorry. This is the best I can do. Okay, second question. An air conditioner has return air of 80 dry bulb and 68 wet. Supply air is 50 dry bulb and 45 wet. Find the delta H. So we literally just did this. So I'll kind of pick up the pace a bit. So let's see, we'll do this with a different color. So dry bulb 80. Whoa, 80 is right here. Okay, and then a wet bulb of 68. Wet bulbs are always diagonal. 65, 67, 66, 67, 68, right there. We're going to follow that diagonal line. And we'll go out a bit. So we got we have 31, 32, 32 and a half. Yeah, let's say that 32.5. And then the supply air is 50 dry bulb and 45 wet bulbs. So 50 dry bulb and 45 wet bulbs. So we find the 45 along this arch. 45 is right here. Follow that diagonal line and follow it out to the BTU, which gives us 15, 16, 17.8. 17.8. So delta H will be 32.5 minus 17.8, which equals 32.5 minus 17.8 equals 14.7. Hold on. Yeah. Oh, cool. Right on the money. Look at that. Delta H, 14.7. Click. On to the next. How many do we got? 14. Okay. Okay. An air conditioner has a return air of 75 degrees, dry bulb 60, wet bulb. Supply air is 55 dry bulb, 45 wet bulb. What is the dew point? I haven't done dew point in a while. Okay, let's look. Hold on, is dew point relative humidity? I know in one of my papers I wrote it down. Give me a sec. Dew point is 59. Oh, okay. Yeah. So one thing I didn't cover was, so in this I mentioned we have our dry, we have our wet bulb that goes diagonal, which also gives us our BTU. So wet bulb, wherever it intersects, this line gives you your grain, but then on the opposite end it gives you your dew point. So in this case, technically our dew point would be about 55, 56, 57, 58, 59. Wait, 1, 2, 3, 4, 5. Why is there 5 lines? 1, 2, 3, 4, 5. Oh, okay. So 1, 2, 3. 58. In this case, 58 is our dew point. So the question is 75 dry bulb, 60 wet bulb. Let's get that plotted. $75 dry bulb. And I guess I will do orange. And 60 wet bulb. 60 wet bulb is right there. Sorry, it's getting a bit much, but this orange line and this orange, this orange line and this orange line. So this point right here. So we're going to draw a straight line, and that's going to give us our dew point, which is right about let's say 50. Is it 50? Maybe it's more like 51. 51. What are our options? What is the dew point? Oh, of the supply air. I plotted the wrong one. the dew point of supply error. I did return error. Alright. Fuck. Supply error is 55. Where? I'm gonna use purple this time. Supply error is 55. And 45 is the wet bulb. 45, which we conveniently already have a line there. Okay. And then we take that point and we go straight across. Like so. So 31, 2, 3, 34, I'd say, yeah. 34. Right, our 2 points, we just went straight across to get the dew point, which would also be our green line, right? Like, really, in a test, I would draw the whole thing across, but evidently I'm doing multiple answers on this sheet, so I'm trying to conserve space. But dew point is 34. Our options are 34, right on the fucking money. Nice. Okay. This is going so slow. You can't rush knowledge, education. That's actually true. You really can't rush education. We should know better than anyone. Anyways, an air conditioner has a return air of 75 dry bulb, 65 wet bulb. Supply air is 60 dry bulb, 45 wet bulb. How many BTUs are being removed from 1 pound of air? So, how many BTUs are being removed? That's just delta H. That's just delta H. Okay. 1 pound of air. Yeah. That's delta H. So, 75 and 65. 75 and 75 goes up like this. 65. So right here. So that line leads to 30 BTUs. And then our other one is 60 and 45. So 60. 45 is right here. You know, I just realized I don't even need to plot this. Really, you just need to know the wet bulb. All you need to know is the wet bulb. If you do 65, because a wet bulb is always a diagonal line. So the wet bulbs are 65 and 45. So if you just go to 65 and you just draw a diagonal line, 30, and then 45, which is right here, draw that out, which is 1, 2, 3, 4, 5. Fuck. 17.8. Sorry. 16, 17. Yeah, we'll just do 17.8, which we already did that. 30 minus 17.8 is 3 2 minus 1, which is 13.8. Our options are... Bella, you having a dream? 13.8, and I see a 12.5. It's definitely not 17, so yeah, close enough. 12.5. Question 5. An air conditioner has a return of 85 degrees dry bulb, 65 wet bulb. Supply is 70 dry bulb and 50 wet bulb. How many grains are being removed from the air? So I think it's time we scrap this piece of paper. And why does it keep zooming? I'm going to use this guy because I am running out of pages. Okay. Let's do this really quick. So we're going to find the 2 grains for your return and supply, and then we're going to subtract them. That's it. So return air is 85. 85. Let's do purple. 85 and 65. Oh, we do conveniently already have a line there that's on 65. And then our grain line will be in the center of that. Shit. That's why I like to use pencil, because it kind of a bit finer. So I'm going to say that's 54. 54 grains, and then the other one is supply air. Wait. Standard air conditioner has a return of 80 and 65 wet. Supply air is a 50 wet bulb. Okay. This question actually is a little tricky. So, back to this. We're going to assume it's design conditions, right? So we have a return air of 80. How do we get our supply air dry temperature? 80 minus 20 equals 60, right? So in the question, all it gives us is, shit, damn it. It gives us our return air of 80 and dry bulb and 65 wet bulb, and then a supply air of 50 wet bulb, and that's it, right? But because it's design conditions, we know that supply air is 60. Hold on, I'm gonna stamp this when I post the video. Number 6 equals 28 minutes. In case you guys want to skip that. So, supply air, what is it? 60. So we find our 60. Where is my trusty purple marker? 60 and a wet bulb of 50, which is right here. That's disgusting. And then, and then we draw our point straight across, trying to remain parallel with the lines, which gives us, I'm just gonna go 40.40. Let's just go 40. So we have 52 and 40, which is 12. Wait, what? What? Did I do this wrong? $85, 65 wet bulb goes over. That gives us, yes. Oh. Huh. Oh my goodness. Somehow my mouse scrolled down. So it does, this question, I am so sorry. This question does give us our supply air of 70 degrees dry bulb and 50. I mean, what I said was still right, but it doesn't apply to this question. Sorry, I have to replot that. Okay. Fuck. Okay, so this is our line, 52. And then we are plotting 70 dry bulb, which I'll do in pink this time. No, I'll stick with purple in case we do another one. We have a wet bulb of 50, which is right there. Where am I? Oh, okay. So 50, I just plotted that. Comes down to here. We're going to go straight across, keeping parallel. Which that will give us 25, 26, 27, 26. Let's go 26. The fuck? That's not near. 52 minus... What? How many grains are being removed from the air? $85 and 65. Line up there. That gives us 52 grains. That's correct. Supply air is 70 and 50 wet bulb, which is right there. And yeah, how many grains are being removed from the air? I'm not gonna lie, I message this teacher all the time. So I believe it's like 28, or I think he made a typo, and I guess we'll find out because I'm leaving this question. Moving on, but I'm going to put 38 grains. 38 grains are being removed. Question 6. Oh my goodness. Okay, new color. A standard air conditioner. A standard air conditioner has a return air of 80 degrees. 80 degree dry bulb, 65 wet bulb, suppliers 60 dry bulb, 50 wet bulb. The outdoor ambient temperature is 82. And the discharge air is has 40 grains per pound of air. Find the BTU of the condenser if the fan... Okay. Okay, this is actually a good question. So I'm going to timestamp question 8. Question number... Wait, what? We didn't do 7. Jesus Christ. We didn't do 6. How does it keep doing that? Sorry. Fuck. Sorry, I'm getting thrown off here. Okay, a standard air conditioner has a return air of 80 degrees, dry bulb 65, wet bulb, supply air is 50, wet bulb. If the system was moving 1000 CFM, find the BTUH. Okay. Find the BTUH. Where's my trusty thing of things? My trusty thing of things. So, key thing. No, a standard air conditioner return, supply air, find the system, find the BTUs. Sorry. I believe it's not this. Total heat. Oh, it's literally right in front of my face. Jesus Christ. Okay, so we're going to do the total heat formula. Total heat is 4.5 times CFM times delta H. So we have to plot. Yeah, I got it. I'm sorry, I honestly tried to do this all really quick. We're at 38 minutes. Okay. Return air, 80 degrees with 65 degree wet bulb. 80 degrees. Degrees with 65 wet bulb. That puts us around, let's just say 30. Supply air. Supply air has a 50 wet bulb. And then I mentioned this earlier. So the supply air, it's not giving us the dry bulb. So we do design conditions. To get your supply air, under design conditions, you subtract delta T from your return air, right? Like pointed out here, if our dry air is 80 and we don't know the supply air, we just subtract 20 to get, so it's 60. So we're going to plot 60. And it has a 50 wet bulb. Where's 50? 1, 2, 1, 2, 3, 4, 5, right there. And I'm going to say that is 20. So our delta H equals 10 BTU per, damn it, 10 BTU per pound. Now, total heat is 4.5 times CFM times delta H. We know our CFM is 1,000. We know our delta H is 10. So let's do it. We have 4.5, oopsie. 4.5 times 1,000 times delta H, which is 10, equals 4,500. No, 45,000 rather. 45,000, and right here we got 43,650, close enough. Human error. A standard 2-ton air conditioner. So per ton is 400 CFM under design conditions. 2-ton would be 800 CFM. So we know that. Fuck. I feel like this video is falling apart. A 2-ton air conditioner has a return air temperature of 80 degrees with a dew point of 50 degrees and has 30 grains per pound of air in supply. All right, this is where it starts ramping up. So, actually, you know what? I'm gonna end it there, and I'll just make a new video for the second half. So questions 1 to 6, yeah.